Finally, let's talk about solving logarithmic equations using the definition of the logarithm. Just as there are some exponentials that we can't solve using our one-to-one property, we also have an alternative method to solve logarithmic equations. Specifically, this involves using the definition of the logarithm to turn a logarithmic function with base a into an exponential function with base a, and then trying to solve from there. Let's give this a shot. Once again, since we have two logs that are being, in this case, subtracted, we need to combine these into a single logarithm before we can use our definition. These are both logs with base 10, and so we can write this as log of 9 divided by x, since we're subtracting, equals 2. And to be very clear, we'll write a little 10 here to indicate this is a log with base 10. Now, solving this equation is a bit of a mess, but if we remember our definition of the logarithm, this tells us that 10 to the power of 2 equals 9 over x. And now this is an equation that we can solve a little easier, because 10 to the 2 is just 100. We could write 100x equals 9, and therefore x equals 9 over 100. Something that's fairly straightforward to solve for this equation, but is very difficult to recognize for this one. In class, we will practice solving equations using all of these methods. We'll also do some modeling with logarithms and exponentials to see what they look like. And finally, at the end of class, I will hand out a card and you can tell me your muddiest point, the topic that you're struggling with the most. See you there.